Okay, we're going to start with number 15 from last night's number. Square root of 4x. Go ahead. Plus 10 equals 9. All right, do you get that the first thing I would do here, trying to get x alone, is to get rid of the 10, and then I have root 4x is equal to negative 1. And if you just continue happily on from there, you've totally missed something huge. Look at that for a second. The square root of 4x has to equal negative 1. Can a square root, excuse me, gross, can a square root equal a negative? No. So that thing's impossible right from there. But if you continue on and you act like you're solving it, and you square both sides, it'll act like, it's working fine. 4x equals negative 1 times negative 1, which is 1. And then you get x equals 1/4. Why is that not right? Because if you actually go back and you put it in, it won't actually work. Like if I take my answer now and put the 1/4 back in here, what's 4 times 1/4? It's 1. What's the square root of 1? It's 1. 1 plus 10 is 9? No. So that's why you can't just leave your answer like this or you get it marked wrong. You may fix it right now if you haven't already and write ext next to it. And usually we have you cross it off, and that really makes it clear that you know it's not a correct answer. So in pre-calc, what you're going to next, the directions will say, identify any extraneous answers. So that'll prevent kids from just going, I don't think this one will work. I'm going to write extraneous right at the beginning. You can't do that. You have to actually solve it, get the answer, check the answer back in and see if it actually works, and that's your proof that it's really extraneous. Extraneous means an answer that's kind of useless. Yes? EXT is a better abbreviation for it. It's very easy for you to fix right now, and you can fix that right now. That it's okay. It's not like I would have marked it wrong. I'm just telling you what we usually do in pre-calc is EXT for extraneous. All right, so next thing. What is extraneous in real life? Is there such thing as extraneous solutions? Yes, there is. I'll give you an example of an extraneous finger. Played poker with a guy. Did I tell you this already? Played poker with a guy that had an extra finger. Instead of 5 fingers in his hand, he had 6. It's fairly common. It is. It's fairly common. And that 6th finger, he had this extra finger down here, a lot of times doesn't actually work. It just is hanging there. And it's like, so this guy that I was playing poker with, he would have his hands out over the table, of course, because you're playing poker, you get cards in your hands, right? And he would hold on to his cards, and he would like take the extra finger that was hanging down and go bing, 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 like bounce it back and forth. It was like kind of like this, except it's this useless finger hanging there, and he was just like bouncing it around, and it was like, ugh! It really, kind of freak you out when you're looking at it. It's like, I don't want to look at that. I think he was using it as a psych job just to kind of mess with your head. And so he'd just play with his extraneous finger. Now, most people don't have those fingers that even were born with them. Because if you're born with an extraneous 6th finger, as in a 6th finger that doesn't work, the parents are usually consulted about that, and parents usually say, yeah, take care of it. And so they basically just have a little tiny quick surgery, and they take it off, and then they sew it back up. In fact, a few of you could have had a 6th finger and never even know it. So how would you tell? You would look at the palm of your hand, like off to the side, and see if there's a little scar there. I'll turn the lights on so you can see. And if you have a little scar there, you might have had a 6th finger. An extraneous finger. So, you have a little scar? Look at that. Interesting. You can find out talk to your parents. Who knows, maybe you just fell down when you were a kid and scuffed your hand, but maybe.
Mr. Server, there was this one guy with one thumb going this way.
I know that there's a movie, one of the James Bond villains had the man with, what was it called again? The man with the golden finger? I don't know. He had a glove that had 6 fingers on the. Now that gold member was a take on an old James Bond movie, which actually existed, which was this, like, so again, that one was a spoof of the James Bond movie. The James Bond movie guy had a glove with 6 fingers, and he was like this ultimate bad guy because he had 12 fingers, two sets of 6 fingers. Okay, anyway. Extraneous. I just thought that's my best extraneous story, so I'd share it now. All right, there are more questions you might have had from yesterday because I wasn't here, and we had a sub, and I know that they may not have taught you much because they just kind of asked you to look through the notes and stuff. So let me make sure you get the main point. When you have a problem like this, would you look in your homework? There was one more like this. There were square roots on both sides. A lot of times, they don't work. They're extraneous. Would you look and see which of the homework problems? Okay, would you read me number 17, please? Let's go over here to Allie G. X minus 11. Negative 2x plus 4. Okay, and so you happily follow all the rules like normal. You square both sides. That's okay to do. And then you get x minus 11 equals negative 2x plus 4. And then you subtract x from both sides. And then you get negative 11 equals negative 3x plus 4. And then you add 4 to both sides. And you get, no, subtract 4. Sorry. Subtract 4. And you get negative 15 equals negative 3x. And so if all said and done, you get x equals 5. And the problem is, it doesn't work. Why doesn't it work? Because you're supposed to go back, especially on this assignment, and check your answers, see if they really work. Watch what happens when I put in 5. I put a 5 in right here. What's 5 minus 11? Is it okay to have a negative 6 underneath the square root? So it's cancel right there. You cannot have a normal answer on this. You can have an imaginary answer, but not a real answer. Because as soon as you have a negative, some kids argue, wait a minute, but if I put the 5 in over here, that also comes out to negative 6 on that side. Well, it's just like saying impossible equals impossible. Anything that's impossible doesn't make sense anymore. So this would be an extraneous answer because it's causing a negative under a square root. So you go like this, you label it as EXT or ES. Yes? You are supposed to check your answers on every single problem, and you know what? To be honest, you've been supposed to check your answers since the beginning of time. You know what I mean? But a lot of times they just work. And so 9 times out of 10, it'll never matter. We're just warning you that right now you're in shark-infested waters. A lot of your answers are going to be very dangerous because they won't work. And you'll think they work, and then you'll leave them as right, and then we mark it wrong because you didn't notice that it's not working. So a lot on this next test. When's your next test, by the way? Well, it's next week anyway. If on next week's test, you should check every answer because you're going to get answers that you'll do just like this. It made sense to me up until I actually checked it. It seemed like it was right. So check your answers because a lot of times you'll get through, get the answer, leave it there, and get it marked wrong because you didn't notice it was actually extraneous. Okay, so double check on this test. We'll kind of warn you when these come up. It's not like you should have to double check every single answer all the time. But whenever there's square roots involved, that's the time when it mostly happens. Yes? What I just did right there is exactly what you do. You get the answer like normal, and you get to the end, you cross it out and say EXT. Yes? There is some stuff to learn. Not a lot. It's more like applying what you've already learned to the real world. All right, so let's get to that. If on today's, I kind of like the fun fact for today, a jiffy. You know, I've heard of I'll get done in a jiffy. Jiffy is actually a length of time. It stands for 1/100th of a second. So scientists that deal in things that happen incredibly fast would actually use the word jiffy and actually have it mean something. A jiffy is 1/100th of a second. Did you know a nanosecond also means something? I think it is 1,000th. I'm not positive. I don't have that one looked up. But a nanosecond actually means a length of time, a teeny tiny amount of a second. And one fun fact about Coca-Cola, translated to Chinese, means to make mouth happy. Now there's other really unfortunate translations, like one of the German companies was selling their vacuums in the United States in the 50s, and they knew that the suction power of the vacuum was really like a cool thing about their vacuum, was like really strong. And so they just said, our vacuum sucks. And they didn't know that in our country that actually meant something different than just like suction power. And so anyway, and nowadays it's kind of become cool to use marketing campaigns like that just get your attention, you know, even though they're kind of like maybe mean something different. Like for instance, that I grabbed some pistachios the other day that had an advertisement that says, grab our nuts. So they're trying to just get your attention with their marketing campaign. But anyway, sometimes the translations are kind of scary. You got to watch out. Coca-Cola worked out pretty good for them. All right. So Lieutenant Bombalo found this cryptic message containing a clue about where the stolen money is hidden. CIN to the 1/1/2 NATI. What on earth could this mean? Well, let's try to figure out what this part means.
Maybe it's caught like sin and total together.
Do you agree that it has a decent chance of being Cincinnati?
Because
Can you tell why?
the 1/1 and a half
The 1/1.5 part, yeah, can be simplified to 2. So sin squared means like sin, right? Natty. Get it? Okay. All right. Anyway, it was just kind of like a, I don't know, fun challenge question. All right. Yeah, we've done a lot of this. I'm going to go to a different smart board here. Get rid of this one. Shrink this down and pause. All right, here we go. I want you to write this one down, and then I want you to break it up into 2 parts, and then I want you to solve it. Every now and then I come across somebody whose brightness is so dim that I can't even see what you're writing. And if that happens, I'm going to ask you to bump your brightness up a little bit. And I see what you're saying. Here. New charger. Different one. Try this one. Now, keep in mind, I got my whole family, and we're going to Israel, and we're going to have a 23-hour flight. So I want to be able to watch movies the whole time. All right. I know. I'm not, okay, not the whole time, but I want to be able to like not have my iPod run out, and plus my kids are going to be like, my iPod's out, help me charge, and I got a charger down. So got a charger for them and a charger for me. They don't get the big one. I get the big boy. All right. So let's turn it on. Is it on already?
Oh my God.
Good. And okay. I cannot explain why it isn't starting right away for you. It's weird. It worked for the last kid, last hour. Try this one. Weird. Okay. All right. Sorry about the delay there. Here we go. You should calm yourself. 125 to the 1/3 squared, and you should know that one in your head. 125 to the 1/3 is what? 5 squared is? 25. All right. Quick reminder of how to do them when they're more complicated. First of all, do you remember that we have to fix what's inside first? Do you remember that x to the -4th is not happy where it is? So you should change that to 16 over x to the 4th. Everybody write that. And we're going to put that to the, And we have three things to do. We have the bottom, the top, and the negative. What order should we do it in? The bottom, then the top, and then the negative. So it's 1/2 power to the third, and then make it negative. When I multiply that all out, it actually still equals -3/2. And I do it in that order. What does the 1/2 powering of this mean? It means the square root of it. So what's the square root of 16? 4. What's the square root of x to the 4th? X squared. Good. And then I've got to cube it. And then I've got to flip it. The negative one means flip it. Final answer, cubed x to the 6th over 4 cubed is 64, in case you had trouble with that one. And then notice I flipped it.
Wait, are you flipping the negative first?
Nope, the 3 first. So I cube it first and then I flip it. I did it in one step. Did that bother you?
Yeah, no, that
I can move it down. Oh, it is x to the 6th. It is x to the 2nd to the 3rd. Like if I just blow up that one part of the problem, do you get that that's x to the 6th? Okay. All right. And then the 4 to the 3rd is 64. All right. So it's 4 to the 3rd means 4 times 4 times 4, 64. X to the 2nd to the 3rd means x to the 2nd to the 3rd means x to the 6th. And then I flip it. The 4 is to the 3rd, and the x squared to the 3rd comes down to a definition. If I'm going to do this to the this, do you get that that's kind of what it is? X squared being cubed? That means x squared times x squared times x squared. Do you get that? That's what cubed means. And so then, that times that times that makes 8. Sorry, not times. I shouldn't be timesing them. That's the problem. Maybe that's why you're thinking it's 8. I should be adding them. This and this and this would add up to 8. 6. Gosh. And this times this makes 6. So I could have just times them in the first place. All right, so the final answer is this x to the 6th over 64. All right, I want to move on to the harder real-world problems. Do you remember this kind of a problem being where you had a starting value of 1,000? Do you remember that? And then this was like the interest rate, right? And this was like being compounded 12 times a year. And this was like 5.5 years. And this is like your total you get when that's all done. Your $1,000 being put at some interest rate 12 times a year for 5.5 years. All right. Well, that same kind of problem is what we're going to have today. And to solve them, I just want to look at this one from the perspective of how do I solve for x? This one's a tough one. But you have to get rid of this and this and this and this to get the x alone. Do you understand that? All right. Then what order do I do it in? You have to get rid of the 1,000 first. These guys are kind of trapped in here, and they can't come out until you get rid of that. So this would be first. This would be second. Then once those guys come out, then I have to choose between this one and this one. What do you think comes next? Do you get rid of the 1 or do you get rid of the 12? The 1. You've done a lot of equations like that, so you knew, a lot of kids know that one. This is third. And the last thing you do is get rid of the 12. All right? So remember, the first thing is what's out in front. The second thing is the power. And the third and the fourth thing are what's inside. And I think those are going to come natural to you. So here is a real-life problem. I'd like you to do this one with me. Get to a blank page. And we're going to set up the equation for this. Now, I didn't need you to solve that one. All right. So this is the first problem. Y equals... Now, don't write this. Just watch. Starting value, times 1 plus the rate over the number of compounding to the years. Do you get that that's kind of how they all start? The starting value in this problem is the kid starts with $500, so I'd put that here. It's compounded monthly, so I'm going to put that here, 12 times in a year. checks his account 6 years later. That goes right here. And he finds out he has 665 bucks. Where should that go? Where the Y is. Do you see how I now have an equation? 665 is how much he has at the end. He started with 500. He has 1 plus the rate over 12 to the 6th power. And now do you get that you got to get R alone? 12 is compounded monthly. That's how many times it's compounded. So like some people pay their bills quarterly. In this case, it's a monthly deal. I have to pay my taxes quarterly. I have to pay my sales taxes 2 times a year, so that's biannual, I think they call it. So there's a lot of different ways you can compound it. Usually it's going to be 12. Most people make monthly payments, so that's a 12. All right, so now see this blue equation? We're going to need to solve that, and you will need a calculator. So everybody grab your graphing calculators. If you haven't got one, you borrow one from me and make it fast. They're up on my desk here. Yes?
You get 6 years, wouldn't it be 6 times 12?
Nope. You don't need to do that. Just put the 6 up where it is. Because this 12 is going to be put to the 6th power kind of anyway. You get what I'm saying? Because it's inside here and it's still to the 6th. All right, so now to fix this, I just told you what order to do it in. That's first. This will be second. This will be third. And this will be last. Remember that? Okay, so how do I do that 500 to get rid of that first? Nope, not 5 minus 500. What do you think? Divide by 500. All right, so somebody takes 665 divided by 500. Say it again. Thank you. 1.33 equals, and now this 500 is gone. 1 plus r over 12 to the 6th. Now, what did I say to get rid of second? The 6th, the 12, or the 1? The 6th. How do I get rid of that 6? I put this to the 1/6. Very good. To the 1/6. Calculator. Keep typing. Now, while you guys figure out the left side, I'm going to rewrite the right side. 1 plus r over 12. What is it? All right. And now what? Subtract 1 from both sides? And then times it by 12. Point what? 0.049 times 12. All right, now. So the kid had his money invested for 6 years, and it didn't grow very much. It went from 500 to 665 bucks. So the rate was pretty low. Does that make sense? I mean, in the real world nowadays, can you believe 0.58 is actually a really good rate? What I get on my interest right now is like 0.25. So this is actually double the interest rate that I get. It's just the interest rates are terrible. In the old days, when I was your age, we got 5%, not 0.5%. We got 10 times as much as you get in the bank for interest. Now, the only thing that's good about that is that right now to borrow money it's really cheap. The rates are really low. Like if your parents wanted to go buy a new house today, the rates would only be 4% to buy a new house. 4% for a 30-year loan. And when I was borrowing money, it was like 8%, okay, to buy my house. So rates have come down a lot, but that means you get less in your savings account too. Okay, so it works both ways. Anyway, here's another problem, and this is the other main kind of problem that you have. They just give you this big formula. See the big formula at the top? That's relating an elephant's height to its age. Does it make sense that the higher the age of the elephant gets, the taller it gets? Until it gets old, exactly. And that's why this square root function makes a lot of sense. If you graph a square root function, here's what it does. It grows a lot at the beginning, and then it tapers off. See how an elephant would kind of do that? It'd grow a lot at the beginning and then taper off. All right, so if you had to solve this problem, you just got to know where to put the number. They just gave me 5-year-old elephant. Where do you think I should put the 5? T, because T is the age. So I put the 5 right there. 13 times 5, cube root of that, add 3. We can see how tall the elephant is. So somebody take 13 times 5, take the cube root of that. You could put it to the 1/3 power. So what is 13 times 5? Somebody help me with that. 60 what? 50, okay, good. And then I put it to the 1/3 power, and then I add 3. Don't forget when you put it to the 1/3 power, it needs parentheses there. If you just type 65 to the 1 divided by 3, the calculator is going to think you want me to do this first and then divide by 3. See what I mean? So you got to put parentheses here. Okay, so what did it come out to be? Say again?
8.6.
Interesting, I'm getting different answers. Who's got an 8 point something?
I'm sorry,
Okay, 0.8 high elephant doesn't make sense to me. 7.0 what? All right, a 7-foot high elephant makes sense to me. All right, that'd be really a mini elephant. I saw one in a movie the other day, like a teeny tiny mini elephant running around, sort of like the size of a dog. Kind of a cool idea. All right. Seriously? All right. Will the average elephant reach 10 feet tall? All right, so then what we got to do is put a 10 where? Is it asking about 10 years? No. 10 goes here. You get how that's like solving the other one? We got to solve for the t now. So you tell me, do you think that I should do this first or the root first? Which one part do I get rid of first? Nope. We have to subtract 3 first. Notice you get it down to the great big clump. You got to get it down to that clump, so this has to be first. Just like on the other problem, we had to get rid of this first so we could get the big clump alone. Do you get what I'm saying? You get rid of this gets out of here first, and then I can get down to the big clump. Same idea on this one. I have to get rid of this first, and then I can take care of this big clump there. All right, so how would I do that? I'd subtract, I'd subtract 3 from both sides, and then I'd have 10 minus 3 is 7 equals cube root of 13t, and then I would, how do I undo cube root? Cube it, yep. And then 7 to the 3rd is some big number, and then I divide that by 13. What is it? 343. That means the elephant would have to live to be 343 years old. That doesn't seem logical to me. So, what the question was, oh, and then divide by 13? Okay. So 343 divided by 13 is what?
26.38.
Now that's 26.38 years old. Now, again, I have no idea how long elephants live. I was going to be willing to bet that they don't live to 300 years old, but I don't know if they live to 26 years old or not. So that's the question then, is you'd have to look up or Google it. Do elephants live that long? So take 2 seconds. You got Google. Go to Google. Don't just trust him. Go look quick. Say how. Stop that. I want people to do it themselves. How long does an average elephant live? I just want you to see you can get your answers now. Instead of just saying, oh, I can't answer that, I need to know something. You have power at your fingertips. You can find these things. You found it in a story? A lot of you came to the same Google search. That's kind of cool. He's got the same exact one as you. And you're coming up with like 60 to 70 years old?
Yeah, 60.
Oldest was 80.
More than 60 years.
Okay, so then by this formula, do you think an elephant would reach 10 feet tall? Yeah. Now, is this a perfect formula? I don't know. I don't know if this is a formula that was gotten right out of National Geographic or if it was made up by some math teacher in the back math office. I don't know. But I can tell you that their intent was to have you say, oh, well, 26 years, is that reasonable? And then you can look up how old does an elephant live, and yeah, that's reasonable. All right. There are some animals that live to be like 200 years old. Yep. There's some tortoises. I don't know if there's really a difference between a turtle and a tortoise, but. All right. In Detroit, they had their population decrease 25% in the last 10 years. All right, so their population has decreased so much that now they have a major problem with too many houses. Isn't that weird? If you don't have enough people in your city and you have like tons of extra houses, what are you supposed to do with them? Like seriously, you would think, okay, let's say that in Minnesota right now we have enough room to house 3 million people. Let's say Minnesota's Twin Cities area for some reason gets to be very unpopular. Maybe there's some kind of a radiation leak or something that causes it to be like nobody wants to live here. Can you imagine that if half the population moved out, we'd have a ton of empty houses? That's what's happening in Detroit. Because now in Detroit they have all these empty houses. In fact, you can go to Detroit and buy a house for $1,000. Seriously. Like a full-size house you can buy for $1,000. I'm not saying a beautiful house in the lake, but a cheap piece of crap house that's in downtown Detroit. Okay, you can buy them for $1,000. I've actually thought sort of about it because people buy them and then they rent them out to people. But then you got to realize you have a house that's like in downtown Detroit where there's all kinds of problems and it'd be really kind of icky to try to take care of all that junk. But there are some investors who are buying these houses up. But the city really doesn't want all these houses around because empty houses cause problems because people go and have gang meetings there, or they go and burn them down, or they go and have parties there. And so what do they do with all these empty houses? They're bulldozing them. So they're just going around a city bulldozer, and if the owner of the house is not taking care of the house, they give them a warning, and if they basically, like say, well, I don't want the house anymore because it's not worth any money, they just bulldoze it down and leave a blank empty lot there. Because they don't want all these empty houses, they're causing other properties around them to get worth less and less. All right, so this is just an example that not everything goes up. Populations don't always go up. Sometimes they go down. So how would our thing change? We'd have a starting value, and we'd have an ending value, like the population of Detroit now and the population before, and it actually would go down. How could that happen? If it's not 1 plus anymore, 1 minus. All it takes is that shift, and now the population is going to decrease by some rate divided by usually 12 compounded monthly. But in problems like this, it's not like monthly population drop. They usually talk about annual. It's probably once. And then the last thing would be the years. Okay, so it could be a minus there if it's decreasing. All right. And we don't have enough time, otherwise you won't have any time to do your homework to watch that story, but it's not that big of a deal. All right, we've already done a lot of this kind of stuff. On this kind of a problem, what would you watch out for? Square roots lead to extraneous solutions, yes, so watch out for extraneous. All right, the rest of the time is your time to work on your homework, so find your homework for tonight. It should be under today's date, which is the 21st, 3-21. Yes, sir. What's the difference between a turtle and a tortoise? Tortoises are only on the land. And turtles are more like water animals. Okay. I did not know that. 250 years for a giant tortoise? Okay, I'm sure that's pretty old. Just think about 200 years, how insane that is for compared to humans. Like when you are about 30 or so, you're probably going to have a kid. And then your kid will grow up to be about 30 and have a kid. And then your kid's kid will grow up to be about 30 and have a kid. And the same turtle's still alive. And then your kid's kid's kid is going to grow up and have a kid. And then the turtle's still alive. And the tortoise, I should say. And then your kid's 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 kid could still have the same turtle. Isn't that crazy? And you would have died a long time ago, and your turtle would still be like in the middle of his life.
That's the same one that's
Nice. Good picture of a turtle.